Have you ever stopped to think about how life's oldest story, a story that started 4 billion years ago, ended up as digital data on our computer screens? It's an absolutely incredible journey through time, and we're about to take it. We'll go from the very first spark of life all the way to the cutting-edge tech that you're going to master. So let's dive in.
Okay, so our story starts on a really early, primitive Earth. Picture a world of just chemical reactions and pure possibility. This is where the very first chapter of life was being written.
So get this, 4 billion years ago, life's original operating system wasn't DNA, it was RNA. As you can see here, we began in what scientists call the RNA world. Now, RNA was this amazing, multi-talented molecule. It could store information, it could get reactions going, but it had a huge flaw. It was really unstable. Kind of like a rough draft written on really fragile paper.
And that's the whole idea behind the RNA world hypothesis. RNA was doing it all at the beginning. But for life to get more complex, to actually evolve, it needed a serious upgrade. It needed a much more reliable way to protect its most valuable asset, its genetic code.
And that upgrade, well, it was an absolute game changer. It led to the emergence of a stable foundation for pretty much all life as we know it today.
The solution, as you can probably guess, was DNA. You know, its strong, elegant double helix structure made it the perfect biological hard drive. It was literally built for long-term, stable information storage, protecting that precious genetic blueprint from getting corrupted. And let me tell you, this shift wasn't just some small improvement. This was the moment life got serious. This newfound stability provided the rock-solid foundation that was needed for all the complex organisms we see today, from a tiny bacterium all the way to us.
All right, now let's hit the fast-forward button. By about 4 billion years, we've inherited this ancient code, and today we have this unbelievable toolkit to work with it. The pace is really about to pick up. First up, we can copy it. Using a technique like PCR, we can take one tiny, microscopic piece of DNA and turn it into billions of identical copies. And we can do it in just a couple of hours. It's basically a biological photocopier, and it gives us all the material we need to study.
We can also cut that DNA with incredible precision. What you're seeing here is how restriction enzymes work. They're like these tiny molecular scissors that recognize and snip very specific sequences in the code. This is what lets us start to really manipulate the blueprint of life itself.
And believe me, it doesn't stop there. We can now edit it. With truly revolutionary tech like CRISPR, we've gone from just cutting and pasting to having something like a find and replace function for the code of life. It's amazing.
And maybe most importantly, we can read it. All of it. This right here is a flow cell from a modern sequencer. Each one of those millions of tiny glowing dots you see, that's a unique piece of DNA being read, all at the same time. This is how we turn that 4 billion-year-old biological code into these massive streams of digital data. So we have all this incredible power right at our fingertips, stretching from the dawn of life to our digital age. But look, this isn't just a history lesson, this is the toolbox of a modern researcher. So the real question is, what does this actually mean for you?
Because, you know, it's one thing to know that these tools exist. It's something else entirely to actually master them. So how do you really do that?
Well, take a look here. On the left, you see the nice, clean data we all want to get. But on the right, that's the messy reality of the research process. You know, experiments don't always work on the first try. The real skill isn't just knowing which button to push, it's understanding what went wrong and knowing exactly how to fix it.
And that right there is the heart of modern molecular biology. It's not just about memorizing techniques. It's about developing the mindset of a true researcher, learning how to think, how to solve problems, and how to master the logic behind every single experiment.
This whole journey from the RNA world to digital genomics has brought us to this incredible point in time. The story of life is still being written, and now we have the tools to write the next chapter. It's time to take your first real step as a researcher, right here, right now.